How long have you worked for NASA?
My whole adult life since grad school.
Really?
Exoplanets are affected by the flares.
Interesting.
So our field with the sun is very versatile, basically.
Cool. Excellent. You know how like the whole solar system is on like a horizontal plane?
Yeah.
Why does it stay on a horizontal plane?
Gravity.
Gravity?
From the sun.
Well, gravity pulls in all directions. That's why planets are round. Do you have something better?
Kepler. So you have to, when it also
to go to the moon in this decade and do the other thing. Not because they are easy, but because they are hard.
3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
The past was hidden by criminals and deceptions. The people indoctrinated by their own delusions. A time of awakening has come. Truth seekers are waking up by millions, and soon the truth will be revealed. If you are listening this, it's time to wake up from your dream and stand up right now. This is not a test. Wake up. Wake up. Wake up. Your reality is just a bunch of lies, told by deceivers and by the rulers of this flat earth. The time to wake up is now. With you now, give some applause to Kevin Bobick.
If you want to get on a non-censored platform, it is going to be RTS.video. RTS stands for Real Truth Seekers. It is a great platform that I have my channel on. You'll also find a lot of other truth subjects other than Flat Earth that are on that platform. Just go to rts.video. It is better than Rumble and BitChute and all the other ones out there. If you want to expand your horizon on different subjects or continue your research on Flat Earth, go ahead and look up rts.video. Jesus Christ is the way, the truth, and the life. Peace. So, if we have the sun and all the planets and even moons and everything, how do you think it stays in orbit if we have a three-body problem here in observable reality?
Very good question. I don't know the answer, but there is a table the Hubble people may know. Come here.
Yeah, sure.
My astronomer friends, we have a question for you.
I have a question for you guys, if you don't mind. So, do you know about the three-body problem?
Yes, I've heard of it.
Okay, cool.
So there's a really good book about it.
Yeah, I was thinking about like the actual observable science behind it. Yeah. If we have like the sun and all the planets and all the moons, why don't we run into a three-body problem in the solar system when we have a three-body problem here in observable reality?
That would be a Mike Garcia question. He's a physicist.
I don't know.
So you guys don't know?
Yeah.
Okay. Have you guys ever seen Mercury and Venus at night?
Yes.
How is that possible when it's on the inner orbit where Earth is facing the day?
It's because it's reflecting the light of the sun. Even if the sun is not directly shining on us during the daylight, like at night when you're able to see it, it's because we're not blocked by our view of the sun, and planets are really good reflectors, which is why you're able to see like a full moon is just reflecting the sunlight.
What? What?
So what do you guys do for NASA, if you don't mind me asking?
I'm doing communications in IT.
Oh, okay, cool then.
Yeah.
All right. And what about you?
He does some really cool stuff.
I work at headquarters on the Roman Space Telescope, but I'm on the program management side, so we deal with money and schedule.
Oh, okay.
And yeah, I'm an engineer by trade, electrical
Okay.
engineer.
So maybe I wasn't asking the right person these questions, maybe, or no?
Yeah. There were some actual astronomers and astrophysicists here.
They will be here in a few minutes. They were just doing some interviews for Fox TV.
Oh, really? So every October, the largest balloon event in the world, called the Balloon Fiesta, is held here in New Mexico. People from all across the world come to this event. It is said to be the most photographed event in the world. NASA elects to come to manipulate the masses with their heavily influenced fake explorations and fully accepted pseudoscience. This year, they came for the 2023 annular eclipse. So I decided I would go have a chat with them and ask them about their heliocentric model. I really don't think that they were expecting someone like me to walk up in there with the amount of ammunition that I have. Yeah. With you? I was actually just by myself. Is that cool? Hey, how are you? Pretty good. Good. I'm doing a short little film. You don't mind?
No, that's fine.
Okay, cool. What do you do for NASA?
This is the Hubble Space Telescope table.
Okay.
Both of us work on the project at NASA Goddard Space Flight Center in Greenbelt, Maryland, just outside of Washington.
Cool.
I'm in the project science office.
Okay.
But the work I do is to try to make sure that other people in the astronomical community can get the best science possible. So we make sure that we do the right things as we're managing the telescope.
Okay, so you basically are in charge of like running the Hubble, and then you transfer the data to someone else to
Well,
make it
I'm
more
one of a
understandable?
large team.
Of course,
that
yeah,
runs
NASA's
Hubble.
huge.
Not
Yeah.
just myself.
Do any of these photos run through a graphics program before they're produced?
Well, they all have to be processed at some level because the data just comes back in digital form.
Over the years, NASA has given us spectacular photos and renderings that reveal a colorful and mysterious universe.
Robert is an astrophysicist turned artist. Tim, once a Hollywood animator, is now a planet illustrator. Together, they produce some of NASA's most popular images, from renderings of how planets light years away could look to actual photos of stars and galaxies captured by NASA's powerful telescopes.
What I'm trying to do is show people sort of the broader colors that the universe has to offer.
It's a delicate blend of imagination and data. The artists meet with NASA scientists over many drafts to ensure a planet or galaxy's look lines up with the research to make each one as accurate as possible.
Okay, cool. So there's not just like one frame shot that you can take that will like show an image like this?
Not in color.
It can take days, even weeks, to produce just a single image. The dazzling final results, enough to keep us all dreaming of the final frontier for years to come.
So when we make a picture in ultraviolet or infrared, like we have here in the infrared, we have to...
That's infrared right there?
That's infrared.
No
of course,
way.
for you to be able to see it, we have to move the image into the visible that your eye can see.
Okay.
So we try to keep the order of the light the same, but sometimes we have to shift the colors down into a region that you can see. Otherwise, we showed you a real infrared image and it would look blank.
Okay.
Or if you were looking at infrared light in the sky, you'd actually feel it as heat.
Interesting.
Your eyes wouldn't see it, but you would actually feel it.
That's super neat. You sound really experienced for sure.
That's fun. I've been working on this for more than 30 years.
More than 30 years? Are you kidding me?
I got involved before launch.
Dr. Kenneth Carpenter. In 1992, he moved into the Hubble Space Telescope Project Science Office as the Operations Project Scientist, providing scientific oversight on both mission and science operations. He earned his Bachelor of Arts and Masters of Arts degrees in astronomy from Wesleyan University in Midtown, Connecticut. and earned his PhD in astronomy from the Ohio State University. During his NASA career, Carpenter has received 9 Special Act Awards and 7 Group Achievement Awards. He has also published more than 70 peer-reviewed papers in astrophysical literature and has produced papers and articles for more than 90 other publications. This guy was the perfect guy to talk to. I really don't think it would have got better than this. Check out this last piece of information about him. He enjoys photography and is an enthusiastic fan of everything Star Trek and Disney. Carpenter credits both Star Trek and the 1964-65 New York World's Fair, when he attended as a child, with fueling his desire to work for NASA. Interesting.
I've changed jobs over the years, but always stayed with Hubble. Okay. It's so exciting to be on one of the flagship missions of NASA.
No, wait, you've been on what missions?
The flagship mission, like Hubble, is an exciting thing.
Oh, yeah, definitely. So have you ever been to space?
No, no. Haven't been in the astronaut corps, ground-based astronomer. Look,
That's
looking,
cool.
Out into the universe.
Yeah. So you're like a pretty well diverse astronomer then.
I try to be. I try to
be?
make sure
Okay.
I understand other people's science enough so we can do the right thing for the community.
Okay, for sure. Doing the right thing is always the proper thing to do, I feel, for sure. I was actually here earlier, and I asked a couple of the other people a few questions about like astronomy and like how the solar system's lined out and stuff like that, but they couldn't really answer my questions. Do you think I could try with you?
Give it a try.
Okay, cool.
If I don't know, I'll tell you that.
Okay, cool. So, our whole solar system is on a horizontal orbit, right?
The planets are mostly in the same
One besides like Pluto, right?
There's deviations a few up and down.
Okay, cool.
And mostly the planets rotate in that same plane, but a few of them, like Uranus, are turn 90 degrees.
Okay, yeah, okay. So what keeps us in a horizontal orbit?
It's basically angular momentum.
Angular momentum?
The solar system forms from a collapsing cloud of dust and gas, and as it spins down and things move in, they tend to collapse into a plane like that.
Okay.
So it's the collection of material, conservation of angular momentum, that's keeping it goes faster and faster to get into the center, but it also pulls things into a planar arrangement.
If you have one little shift in angular momentum, even after the first spin, it will slow down or speed up the spin, or in this case, the orbit, and objects will get closer or further away. Some things to take into consideration is Earth's elliptic orbit, axial tilt, let alone all the meteors, asteroids, space debris, etc. Between that, gravity pulling in all directions, and the three-body problem, the entire solar system falls apart.
Do planets ever get closer due to the angular momentum?
They do in the early stages.
In the early stages?
Things will move in.
Is that observable?
Well, we don't see it very much in our own solar system, but when we look at planets around other stars, sometimes we see planets close into the stars that make no sense.
What? What?
But we have found some of them that are getting really close to their parent star.
Okay.
And we don't think they could actually form there. They would be too hot. They'd be gaseous. The light atmosphere would boil away.
Okay.
But if they formed far out and got drawn inward of the solar system, then, maybe that's how they ended up there.
You'll be listening to some guy and say, well, he's fairly intelligent. He's full of shit.
Another question I was asking them, and they referred me to someone else, and they referred me to an astrophysicist. Have you heard of the three-body problem?
The book or the actual?
No, like the actual observation, the three-body problem. Right? So in observable reality, there's a three-body problem trying to get 3 bodies of mass to orbit each other. Right?
It's hard, not impossible. But
you can get 2.
It's easy if you have 2 close together and 1 further out.
Okay.
That 3-body problem is pretty stable.
Okay.
Because the third body just orbits the
Have
center
you
of
done that in
gravity.
a computer, or have you done it like in real life?
Well, I don't do that kind of calculation. people have done the calculations.
Okay,
Computers
so
and with mathematics.
no, I feel you. So if we just have a three-body problem, like in observable reality, but in the solar system, we have the sun, 8 planets, 146 moons, we have asteroids, we have space debris.
And we have modeled that motion very well.
You've modeled that motion?
Well, I haven't, but we know, we can as a community predict the motion of the planets down to very high accuracy.
So you don't think the three-body problem would be a problem for all of the solar system? We can't even get
Only, it's really a problem when things are very close together. When they're spread out like they are in the solar system, you can handle it pretty well.
But I mean, you are seeing like asteroids get flung out.
Well, yeah, the question was, were you saying how hard is it to model it? Or?
No, like, yeah, like how hard would it be to model like in real life? Like, because I've seen like the giant spandex, like trampoline thing, you know what I mean? Where that guy, he has the two balls and he throws them and they orbit each other. If you throw another one in there, it just throws all of them off completely.
Well, you can see it with Ada Karina.
If you don't mind, I'm making a short film, sorry.
Yeah.
I know you're talking.
So this guy was actually quite pleasant to talk to. He is a video producer that has an astronomy background. But once you start bringing up the three-body problem, then all there is to talk about is theories.
Of Uranus and Neptune, and this is a theory, but
okay.
So three-body problem. What was actually your question?
Well, like I was just curious how much that would that affect it if there's a three-body problem. It's obviously called a problem for a reason.
I think there is potential, and this goes a little past my expertise, but a problem, as in a mathematical problem, I think, as in like a proof.
I would just think like an observable, repeatable, testable experiment, data, hypothesis, conclusion, independent, dependent variable, in a controlled environment. There is a three-body problem. But in our reality, or in the solar system rather, there's...
Like, I think you are also, just because, say, in an independent, testable situation, just because we not necessarily are able to determine what it is right now doesn't mean we can't in the future. So, 50 years ago, we weren't able to do the things we can do now. So, I'm not sure.
So maybe in the future we can do it in a controlled environment.
I'm not stating that because this math is beyond me.
Well, I'm not really talking math, to be honest.
Like physics, if you're doing the actual, the three or even more. So that's beyond me to answer, with an assurity of saying, I represent NASA and saying that's the answer. So I wouldn't go that far because I'd probably be wrong.
No, you're fine.
I'm not smart enough.
It's all good. So what do you do for NASA? I got his credentials.
Yeah, I'm a video producer. So
you're a video producer?
I have an astronomy background, but not to his degree. But so something interesting will come out. Or not space.
Yeah.
Like a daily TV show with my wife.
Okay.
That's still good.
No, that's cool. That's cool. No, that's good. All right. Do you mind if I get a picture with you? Is that okay? Okay, cool. I'm gonna ask him if I get a picture with him too, but.
Very good.
Cool, excellent. So one more question for you gentlemen, if you don't mind. So earlier we just viewed the total solar eclipse, which was awesome. What do you guys think?
It's always amazing.
It's always amazing, right?
I've never seen an annular before. I saw the 2017 total. It was cool. I do like the totals better.
Yeah, definitely.
But no offense to the annular, but it was, the Ring of Fire was cool.
Yeah, more of an astronomy question, if you don't mind yet again. So what happens with the solar eclipse is we have the new moon get in front of the sun, obstructing the vision, right? And then it's projecting a shadow on Earth. But the shadow that's projected on Earth only comes to about a few hundred miles, right? But the diameter of the moon is 2,149. But in observable reality, the shadows always get bigger in real life. This is the only phenomenon, ever, where shadow gets smaller. You guys have an answer for that?
Well, it's just the depth, the total darkness part of the shadow converges down. There's a lighter obscuration called the penumbra around over a broader area. It's just that you have two spheres, and it's the way the light is blocked by the smaller sphere of the moon going down.
Even in the East Coast, when it's not cloudy, 30% was blocked. So the penumbra was still.
It's just the viewing angle changes enough. You have to be directly on the line to get that ring of fire that we saw here. If you're off a little bit from one side to another, you're not looking directly at this. You're looking
for sure.
off the side.
But it's projecting the shadow onto Earth, right?
Right. Well, it's projecting the shadow all through space, and the Earth happens to be in the way.
Of course.
A small part of the Earth.
But it's only a few hundred miles in diameter, but the moon is 2,140 miles in diameter. So the shadow is getting smaller as it projects onto the Earth.
Right, and that's true of any, if you...
I think first off, the moon's 238,000 miles away, I think. Did you say?
Yeah, I think what's really relevant is not the absolute size, but their projected area on the size on the sky.
So do you feel like you could do an observable, repeatable, testable experiment with data hypothesis, conclusion, independent, dependent variable, in a controlled environment, proving a shadow getting smaller from 3
I think you could do that in the lab. People have done it in the lab. Just get two spheres with a bright light source. You'll see the same thing.
You'll see the same thing, right?
Yeah, yes, it's not unusual at all. It's just the way the shadow of a sphere projects through space.
Okay, so in a lab, you think you could do it? You think you could make a shadow get smaller?
Yeah, if you're illuminating a sphere from a distance, that's what will happen.
Okay.
When you go home and try it with a tennis ball or something.
Well, I have before.
Or maybe a beach ball. The shadow that projects down, you have this really dark interior core, and then around that a lighter penumbra, and then an even lighter area around that. So you're probably seeing that spread out area when you say it's larger, but
No, I feel you though, but you see, further I get, the bigger the shadow gets.
But see how it's dispersing?
Yeah.
But it's getting it's feathering almost, which would be penumbra.
But it never gets smaller though.
Well, you're using your hand first of all. You're not using a sphere, right?
Well, yeah. Well, we can use a sphere. We're gonna see the shadow get bigger.
But I mean, also though, we're in a scenario where we have multiple light sources bouncing all over.
You've got a light source that's 93 million miles away.
Yeah.
So you in the testable
controlled
environment you're talking about, it wouldn't be your room, it wouldn't be your family.
The other thing to think of is the sun or the stars are far enough away that the light beams from the sun or the stars are effectively parallel.
Okay.
As opposed to in a room like this,
light is bouncing everywhere.
Well, how come whenever I look at the sun's rays, they come out crepuscular?
I don't know what you mean.
The sun has crepuscular rays. It has angled rays. It comes from up, it comes from down, it comes from every angle.
So the ones that are coming up and down misses completely.
I actually have a picture and observation where it's spread out from everywhere. It's spread out from the top, it's spread out from the bottom, it's spread out from the sides.
But it's not going to hit the Earth. Only the light directly coming to the Earth.
So, well, the light that is easily observed from the sun will crepusculate, or have crepuscular rays rather, in all angles.
You mean off the atmosphere? As the light comes through, it hits the atmosphere and spreads out. That's
it's usually in the clouds.
Yeah,
It would be bouncing off clouds.
when you're talking about the moon and the sun, you're in the vacuum of space. You don't have any of that happening.
So it's not going through a different medium, in other words.
Not a dense enough one to make any difference. If you go through large interstellar distances, the light can be impacted by the interstellar medium. But there's not a whole lot compared to the brightness of the sun.
Especially from the sun and Earth right now, there's not.
It's a very short distance and very low density material.
You guys do, so you're saying that the rays from the sun come in and then it hits a medium and it's dispersed out, and that's why we get crepuscular rays.
I'm not sure where you're going.
I'm a little lost on the actual question.
But that's irrelevant for what we're...
Yeah, sorry. I just really segue to a different subject.
So if you truly do the experiment on the ground with parallel light coming from a point source far away, you'll see that this pattern of dark core, penumbra, and further out.
It really is the importance, though, because imagine the sun. The sun is surrounded by space and Earth, and you really have to be aware that when you do this experiment, that you can't have light reflecting. Because the second you have either multiple light sources or you have even a wall, you're getting light bouncing off, which will affect your end result.
Okay, so you're saying if I did it in a dark room with no other light, that I can get that shadow to shrink?
It's not even. You do it in a dark room with no other light.
And then I have one light source, I use a sphere, and I have something to project it
As
on.
long as you're guaranteeing that there's no light in your dark room, because when you turn on the light, you're no longer in a dark room.
Of course,
As long as there's no light that's then reflecting off of a wall or something.
Then you think the shadow will get smaller?
If you have true parallel and illuminated light beams coming in,
true spheres.
Probably most sources of light you have around the house aren't really producing that kind of light.
Yeah, so if I got even like a laser light.
That might work.
That would come out parallel for the most part.
It would. I think. I
play around with it.
I want to see, you would need, people looking at your setup to make sure you're not searching for a result that matches up with your hypothesis.
No, I completely understand.
Yeah.
Okay. So, do you mind if I ask one more?
Absolutely.
Okay, cool. This is fun for me. I'm sorry. I've heard different theories about this one, and none of them really stuck with me. We have the troposphere, stratosphere, mesosphere, thermosphere, exosphere, right? And it goes to high to low entropy air molecules, right? What's containing the air pressure?
Well, gravity is holding the atmosphere onto the Earth.
Well, gravity's not a solid container. You have to have a solid container to actually have it contained.
No.
That's actually the second law of thermodynamics.
No, but if you have enough, if the gravity is strong enough to prevent the gas particles from achieving escape velocity, it'll stay there. If the atmosphere gets too hot and the gas molecules move too fast, they will boil off. Okay. That's what happened early in the solar system. That's why something like the Earth doesn't have a lot of hydrogen and helium in the atmosphere. That all boiled away. Because they're very light elements. When you heat them, they move very, very quickly and they disappear from the planet. But heavier molecules like oxygen, nitrogen, methane, there's enough gravity in the atmospheric layers to keep it there.
Okay, cool. Well, in a controlled environment, yet again, an observable, repeatable, testable experiment, air pressure has to be contained by a solid container. Unless you can prove to me that gravity can contain air pressure here in a controlled environment.
But I think it's not a contained environment. You do have escape.
That means the atmosphere would escape then. The air would escape. You can't have a solid. You can't have a negative pressure system against a positive pressure system without causing an equilibrium to opposing forces, causing a balance in nature, or having a solid barrier in between the two. In real life, observable reality, that doesn't happen.
No, that's not true. If a strong gravitational force holding onto the atmosphere, if the particles don't achieve escape velocity, they're not going to leave the atmosphere.
Can you prove it?
Listen, this is getting ridiculous. I would
Thanks,
like
guys.
to stop the conversation.
Okay, cool. No worries.
Yes, we can prove it. I'm not going to do it.
So you can't do it in a controlled environment here on Earth, though.
What was that?
You can't do it in a controlled environment here on Earth.
The Earth still has an atmosphere after
I mean, we
5
are.
billion
Yeah,
years.
we're literally doing it right now by being able to breathe.
Or we're being contained by something.
Well, you also have to remember that the Earth's atmosphere gets replenished by volcanoes and things as well, although that wouldn't be enough to keep it this beautiful atmosphere around us.
Exactly.
But it does add water
So
vapor.
you're a firmament believer?
I am.
I mean, why?
Well, one, air pressure has to be contained. Every time I take my Nikon P1000 or P900 to zoom into the say Venus, I see water going through it.
Are
You're not talking the same. It's not the same thing as looking at an atmosphere hanging on to a sphere of matter. Any experiment you do on Earth is not going to have the mass of the Earth in your little experimental lab.
So in other words, a lot of the heliocentric model can't be proven on Earth then.
We can observe the motion of the planets.
So what would you say the best proof of Earth's motion is?
Well, we can see the motion reflected in the reverse motion of the stars, for instance, above us. That's one way to measure it. We also know that for the sun to hold the Earth in orbit around it, there has to be a certain gravitational attraction, and the Earth has to be moving below a certain speed, or it would actually escape. The fact that it doesn't is moving slowly enough that the Earth's gravity can hold it in. Because basically, as the Earth orbits around the sun, it's falling toward the sun, but it's moving fast enough to not fall into the sun. Any spacecraft orbiting the Earth is the same way. Hubble's moving around at 17,000 miles an hour. In effect, it's falling toward the surface, but it's moving so fast this way that it never gets any closer.
Okay, so you're saying the Hubble telescope is traveling how fast?
70,500-ish miles an hour.
Okay, cool. So back to your first initial statement when it comes to the stars and the sun, couldn't it just be the stars and the sun moving and not Earth? If you look into the Michelson-Morley experiment, Airy's failure, Sagnac table experiment, they all prove Earth to be motionless.
The chances that all of the stars over the entire sky are moving in a coordinated fashion to mimic the Earth's motion through it is infinitesimally small. In most cases in science, the simpler explanation is the right one. Maybe not always, but in this case, it's far simpler explanation that the Earth is moving through this universe of stars, through this galaxy of stars, and we see the reflected motion by looking at the stars. The odds that all of the stars in the galaxy are moving together in a way that makes it mimic the Earth moving through that, or the sun moving through them.
Because I guess for you, who's doing this? Who created this?
Who created what?
The dome. Who created it?
Well, obviously it was a creator. In the beginning was the Word, and the Word was with God, and the Word is God. He uses the firmament as a footstool. He's that big, so he could make the stars rotate.
I think unfortunately with this, you're kind of at an impasse where.
Well, you're also talking about a trickster God that's trying to, Loki. He's got no need to do that. If God wants to do something, this is my personal opinion. I'm not speaking for that.
No worries.
If he's all powerful, he can create the universe originally in a fashion that's to be observable past the way we see it. To be observable past the way we see it. To be observable past the way we see it.
Okay.
You're limiting the all-powerful God if you said
Very
you
subjective.
can't do that.
Very subjective. So I think that
Flat Earth. So at this point, they know I'm a flat earther, so there's nothing to hold back. and you can see Mr. Carpenter kind of walk his way out of the conversation.
What about the tests that have been done where roughly, but you had the laser beam that went a mile or so, and the laser beam was supposed to hit a point if we were in a flat Earth, but then it was clear that there was curvature. So I think if you argue we're in a dome, you have to believe that you're flat Earth.
Topographically level, yes.
Okay,
There's also many things like we could do a sextant, we could do a laser through long distances. Also infrared. There's infrared images showing island masses and mountains from way too far away with absolutely no curvature being sighted anywhere.
So
we also have the salt flats, we have the abyssal plains. The abyssal plains is known to be the flattest place on Earth, and then water also takes up around 20 or 70% of Earth is what we're told. So it's all left.
I just mean, but like I'm forgetting his name, but we proved this 2,500 years ago with the well and the noonday sun experiment.
Eratosthenes?
Yeah. Have you
So,
try that experiment.
Okay, so what we can do is do that experiment, but if we look at the sun rays, they don't come in parallel, they come in crepuscular, and if you do the same experiment on a flat Earth, it makes complete sense.
You've done the experiment, though, with someone that you trust at the same time?
I've never done Eratosthenes experiment. We're looking at observable reality with the crepuscular rays. That throws off the entire hypothesis of Earth having curvature and it being proved that long ago.
I mean, that's what I'm saying. We're at an impasse then, because like if you're not willing to,
I'm observing reality. I'm observing that the rays do not come in parallel.
I mean, it's your reality. I think that's where we're at. Like, I mean, and I respect that. I mean, I hate the whole like calling. I'm just gonna call you a flat earther.
Yeah, that's fine. That's fine.
But I hate that they're mocked, because I think you guys are looking for answers.
Yes, thank you.
But I think you're doing it in the wrong fashion, and we have so much history with how things actually are, and it's come to the right side. Right? and here at the same time, though, you're doing the same thing, and you're saying come to the right side here. So
yeah,
that's why I'm saying like
I
don't know. I think we can have these conversations, but
well, I appreciate you having the conversation.
I think it's I don't know what to say.
See, well, us flat earthers, what we're doing now, we're going out, we're doing our own experiments, and we're not finding curvature. We're knowing air pressure has to be contained. We're observing stars don't have parallax.
We're not finding curvature.
No, nowhere. Nobody is anywhere. That's the problem. After the Nikon P900 came out, we can zoom into distances that shouldn't be there.
Why are you? I'm still stuck in that the noonday well experiment.
Eratosthenes.
I'm stuck on that personally.
Well,
that proves it. But no, but that's the thing. You're trying to.
The hypothesis.
But no, wait. Sorry.
Okay, go ahead.
You're trying to. If you were to do that experiment, I think the result would show that there is curvature in the Earth. But then your answer is you then kind of tap dance and matrix avoid saying, oh well, it's not that way because the sun rays are doing this.
Okay, so Eratosthenes
experiment.
Eratosthenes experiment goes off of the hypothesis that the sun rays are coming in parallel. We can observe the sun rays coming crepuscular. That destroys the entire experiment.
Does it?
Yeah, it does.
Like we both think the other is silly. I don't know. There's not a whole lot, and like I said, I'm a simple country video editor. So
no, honestly, I really appreciate the conversation because just like you said earlier, there's people that attack us flat earthers, and all we're trying to do is just do different experiments.
Yeah,
you know what I mean? Yeah. And so I appreciate you having the conversation after me telling you.
I think the thing is like stay humble. That's what what is it? The 500 years ago, Kay in Men in Black. 500 years ago, everybody knew the Earth was flat. 100 years ago, everyone knew that the sun was the center of the universe. So we're constantly learning these things, and people have died because of these things we've learned. That the sun is the center of our solar system, and the Earth is going around.
There's no proof of motion. There's no proof of curvature. There's no proof of axial tilt. The stars should have parallax. The North Star Polaris stays in its position, but we're supposedly tilted on an axis.
Really, it's a
so why doesn't the North Star Polaris move?
The North Star does move over
that not observable reality.
You have
we have no proof of that.
You have archaeoastronomy.
That's archaeoastronomy that we cannot prove or touch nowadays.
And see, then once again, we have evidence of archaeoastrologers who have seen that a North Star wasn't always Polaris because of precession, because of the Earth's tilt.
Well, then
you're saying here we have evidence, and now you're saying that some trickster god put that evidence there to trick us. It's kind of the people that say the devil put dinosaur fossils there to trick us into believing that the Earth is only 7,000 years old.
Well, there's never been a full dinosaur fossil found.
See, you don't believe in dinosaurs?
No, heavens no.
How old do you think the Earth is?
I honestly couldn't tell you.
I'm not gonna. That's just the way it is. If you're that level and I'm over here, I think we can agree to disagree.
I'm okay with that. I appreciate you being so friendly with me, though. Thank you so much.
You have a great day.
You're awesome. Thank you so much.
So the conversation went and ended very well. I didn't get a chance to say bye to Dr. Carpenter, but I wish him the best. It seems to me he's a guy doing his job, but that's where people don't understand departmentalization. That's where sometimes just planting a seed is all it takes. The person who told me about Flat Earth isn't big in the movement at all, but look at the ripple effect that had. That's why I appreciate everyone in this movement. Whether you're doing something big or small, we all matter. I wish I could go back to the content creators I've been paying attention to the past 7 years and just say thank you. It's a huge deal to be with this movement, and it's a complete honor to be amongst you all. You'll never know how important this movement is until you join it. The ones that aren't are living with a huge veil over them, and they don't know how freeing it is to wake up to this. I wake up every day thanking God for the life I live, knowing He's using Earth as a footstool, looking down upon me like the inhabitants of grasshoppers. Once you realize that, you stop living with so much mental, physical, emotional, and spiritual bondage. So if you're part of this, keep your head up. At least we know up and down is a real thing.
What do you do for NASA, if you don't mind me asking? Are you like a scientist or like a data?
We have a rocket engineer. I am a scientist by training, but I'm a hybrid.